welcome. I am Piers Ridyard, CEO of the decentralized finance protocol Radix, a public ledger entirely focused on bringing DeFi to the mainstream. This is our podcast, The DeFi Download, a show about decentralized finance and all things crypto, where we dive into the details of the projects, assets, and services that are powering the DeFi revolution. Today, I'm joined by Brendan, CEO, and Andrew, CPO of Notoros. Notoros has developed a protocol that has made it possible to build any application on Radix. Thank you so much for coming on the show, both of you.
Thank you for having us.
Thanks so much for having us.
So let's just start off with that. What do you mean by any application? Like, give me some example. What is that? Any application?
So any application really means any application. Because of the way our system is built, it's so generalized that we can really adapt it for any kind of smart contract system, or even some sort of non-smart contract systems that just run on, sort of traditional Linux kernels and those types of things. But our system really allows you to take any application and just distribute it across the Radix consensus algorithm, without really missing a beat.
That's awesome. So I could take, for example, Solidity and I could run it on Radix?
Yeah, absolutely. That was one of our first proof of concepts that we developed, actually. It's if you can show that Solidity, a Turing-complete language, can run on Radix, then any Turing-complete language can run on Radix, which means that any program can run on Radix.
And what other things have you played around with as well? Have you tried any other virtual machines, any other environments?
Yeah, so we're exploring a lot of different virtual machines. One thing that we're really excited about is our IoT message bus, which makes it really, really easy to onboard. And that's, for those who don't know, that's Internet of Things, or like edge sensors, or sort of any sort of smart device you might have. And really making it easy to onboard those onto the blockchain, onto Radix.
That's really cool. And this opens up a world of opportunities for different application that may have already been built in a VM, and you're like, this would be great as a decentralized application. What have you found as the challenging things of getting people to go from thinking in a traditional, I have a server that's running an application, to, oh no, now I have this decentralized network that is somewhere. I can't put my finger on where it is, but it's somewhere and it's doing some stuff.
Well, I would say 5 years ago, it was a lot harder to explain what blockchain is to people, but now everyone's kind of familiar with cloud computing. And so the way that I like to explain whenever you're building a blockchain application is you just think of the blockchain as your cloud database. And it's a database that everyone can use. Everyone can see what's going on inside of it. And if everyone has access to it, then you can distribute that across the globe and get really reduced database costs, really reduce latency across entire regions. And it operates as a much more resilient database effectively. And if you think about things like that, then as an application architect, it kind of falls out, this is where, if everyone has to have their database next to them locally, then I also need to have their server running with them locally. So I'm going to distribute an entire package to them. And that's going to distribute my architecture across the network. And I don't actually need to have my own website anymore.
Yeah, I mean, that's like the first time I came across Ethereum, that was the thing that sort of blew my mind. In fact, it was the thing that I thought was the reason that it was made up. Was there was I can remember there just being this video of Stefan Tool being like, now you can build unstoppable applications in a serverless environment where there's, and I was like, what the hell is this guy talking about? And then fast forward 5 years, it's my life. So you guys have got some really interesting sort of background histories in how you came to Radix and why you guys sort of what this search that you went on. It would be great to talk a bit about what the kind of things you tried to build before using blockchain and what the early experiences you found of building things for businesses. Brendan, you were saying that you tried to build a website advertising platform. It sounds like a great story. Please tell me about that.
Yeah. So one of the things that brought me to Ethereum was this concept of a decentralized web. And when you look at the web today, there's kind of this power structure where the advertisers have complete control over the way that the money moves around. So the advertisers are what funds the website. So they are able to control what content's on that website. And you're not able to pick which advertisements on that website. algorithm kind of just dictates it for you. And so you're constantly being manipulated as a user. The website has like less control over its own content, and the advertisers sit at the top of this power structure. And that's only because you don't have a way of paying the websites for their content directly, not in a way that's like financially efficient anyway. And so they're able to do it because they're very cheap. And I thought we could replace this with blockchain tokens. So you're just able to send a token to the website instead of having to do this complicated advertising exchange. They can give you ad-free content, similar to what we have for subscription models today, but just on an ad hoc basis. Now, if you imagine scaling that up to the scale of the web today, every single YouTube video being paid for with a transaction, every single time someone goes to Medium and reads an article, every single time someone watches an advertisement and gets paid to do so, all of these cause transactions on chain. And there simply isn't a blockchain out there, or there wasn't, that was able to meet this scale. And I tried different things. I tried batching, I tried state channels. There was just nothing out there that could be as responsive and handle the throughput that was needed for this type of application.
And what was the throughput that you were sort of able to get to? Like, where were you maxing out, and where did you sort of see that you needed to get to for this even to be a viable model?
So with transaction fees, we needed transaction fees to be less than 2.5 cents per transaction. And with batching, we were able to get them down to about 2 cents on Ethereum with a whole bunch of state channel proofs and stuff. But then gas fees started to explode. And that was a problem. And then we started looking at how big can a block actually get, how many transactions can fit in a block. And then that ended up being a problem. And so it was about 100 transactions per second was what we could handle. If that ended up being 12 transactions per second on Ethereum, batched up and rolled up and stuff. And that would have handled maybe like one city's worth of page views in a small town, not a big town. No, certainly no Los Angeles size thing. I'm going to handle that. And it was just like, okay, well, this was a cool, fun idea. It's funny. Invisibly came out at the same time. They had a very similar concept of using tokens on the back end, and Brave came out shortly after that and did a similar thing. So it's a hot topic, but no one's able to really kind of get to that final push of world adoption.
Yeah, that's really cool. And Andrew, you also had a really interesting thing that you guys built as well, right?
Yeah. So I originally got into the space right after getting out of grad school, and my background is actually in the energy industry. I tried to make my thesis about peer-to-peer energy grids, but nobody really knew what a blockchain was at the time. And after my grad degree, I started working for an airline loyalty exchange.
Right.
And really, they wanted a platform that could do it all. They were looking for something scalable and granular and incredibly cost effective. And just kind of there was no solution at the time. I explored a bunch of different options, and we ended up landing on Hyperledger at the time, but I don't really think it met their needs.
Right.
And ever since then, when I discovered Radix, and when I met Brendan and we started building Notoros together, it became really clear to us that this was kind of the platform that we could do everything with. And that's what got us so excited about this space.
Awesome. And it's really interesting. People don't think about it, but companies do treat loyalty points like cash in many ways, right? Because it represents a real cost to their business, and there's huge numbers of transactions being done with them. And in many cases, those loyalty points can be spent in more than one place, more than just on the website for that airline. And suddenly you have almost the same problem set as cash or like financial transactions, but there's no systems that are already built that do it, because you sort of have to roll your own now there are, but back then when it was first becoming people rolled their own loyalty point systems. And so a lot of them are built on these really funky architectures, and fundamentally you're this is important as cash. What we've done is we built a shadow financial system with none of the standards that can't follow. Don't have PCI standards, don't have data integrity standards, and this is a real problem for airlines. And there was this time where I was man, loyalty points are going to be the way in which blockchain adoption gets pushed to the mainstream. I'm still like, I'm bullish on loyalty points being a huge use case. I'm now that DeFi started to like really ramp up and people are like, oh my God, I'd like 10% on my cash. Like that might nix it. But from the point of view of like a massive problem to solve, it's probably up there with some of the biggest ones. The other things is things like ticket booking blows my mind, because think about it, you have an airline, it's got seats, and any one of those seats could be booked by 100 different companies, but you need a way of making sure that it was only spent once. And like, what you don't realize is how often that goes wrong. And like in America, overbooking is a thing, right? Like you turn up and you're like, whoops.
Yeah, it's not an accident. It's on purpose.
Right. That's on purpose. Sure.
And what's really cool too is as these spaces begin to merge, really we can even start to combine like the ideas that Brennan and I have talked about. You could have airline loyalty points that you use to pay the companies whose content you consume on the internet, and really sort of just shorten the financial supply chain, so to speak, and really make everyone just have a lot more financial freedom in terms of what they deem valuable and how they want to reward the people who provide the goods that they consume.
That's really, really cool. That's really cool. So let's talk a little bit about what you're actually building on Radix, because I think that a common question you probably get asked is like, is it a layer 2? Is it a layer 2 for Radix, or is it something else?
So it's actually a very common question. Everyone seems to be a little bit confused, and this is actually just because of the way that the space has evolved. If you look at every single layer 1 that's
because the space uses the wrong words. Exactly. Layer 2 is nonsense. It's a nonsense word.
Exactly. If you look at everything that's out there, you have your blockchain, right? That's your database, and then you have something that you do with the stuff that's in the database. And for Bitcoin, it's transactions. You're just looking at who says I want to send this from where to there. And then you have special rules about what can go in the database and what doesn't. But for the most part, you have a database and then something that you do, and that's your layer 1. But it's actually 2 parts, right? There's 2 parts there. And so if you separate that out, that application layer away from the blockchain of the storing your data and then figuring out what you do with it, that's where Notoros lives. We call that layer 1.5. Because the word layer 2 is already taken. So we have to squeeze ourselves in there as layer 1.5. And I think that really fits with the way that most people kind of envision blockchain today, is it's somewhere between your core consensus and then a completely different network that does something in addition to your network. That's where Notoros lives, is in that layer 1.5 area.
Right. So basically, I'd love to talk a little bit more about this, but there's something special in how we do state transitions and sort of generalize the concept of a state transition that's made that possible for you. But the way that I sort of think about it is what consensus is for is agreeing on whether or not something happened and then storing that in the database, what you're describing as the database. But the thing that happened, you can kind of set any rules as to whether or not you classify that as valid or not. And on Radix, there's this way of basically going, we're going to set our own rules for how the nodes can come to agreement on a valid thing or a not valid thing. And as soon as you have that, you can kind of just you have your validation transition and you have your right transition post agreement, and you can kind of then just put anything on top of that, right?
Yep, absolutely.
Yeah, this is a really cool idea, and Radix's consensus is like really inspired in our point of view. In many ways, the inspiration for our technology, and what's really essential about the fact that Radix can do this consensus layer is Notoros actually shares the security and finality with Radix at layer 1, which is why we're very hesitant to refer to our system as a layer 2 at any point, because those systems really are only as fast as the complement of the layer 2 plus the layer 1. So they'll never be as fast as the layer 1, whereas Notoros operates at layer 1, has the security and finality of layer 1.
So like how can someone think about let's take, I know that you do a lot more than Ethereum, but let's take the example of Ethereum or the EVM running on Radix. Like, what's actually happening there? Like, how have you repurposed the EVM and made it work?
So what we did is we took a look at the way that the EVM itself is its own state machine. It says, take these inputs, perform this function on them, and then give me a new output. And currently, the way Ethereum works is it says, give me all of the inputs that are ever there, and I'm going to do some small thing, and then I'm going to give you all of the inputs back out as outputs again. And what we just said is, well, if you have a function that just says, I need variables A, B, and C, you don't need the entire alphabet. And so what we can do is we can say, just find the spots where variables A, B, and C are, and then separate those out, and then run that function on its own. Give me just the outputs of A, B, and C, and then I'll recombine that with the rest of the stuff that I'm doing at the same time. And that's how we're able to parallelize what the EVM is doing. And that's how we're able to kind of mount it on top of Radix, is that those same state transitions that are happening underneath Radix, those are just kind of holding on to those variables and making sure that they move around on their own appropriately, instead of us having to monitor the whole Ethereum environment at once.
You can kind of think about it as like, if you buy coffee, your coffee purchase shouldn't be dependent on a guy in South Korea who's, buying dinner. Like, those transactions are not really dependent on each other. They don't have a lot of overlap in the people or the businesses they affect. So this basically separates those out and isolates them to the parts that matter.
That's really, really cool. And and you guys didn't start looking at Radix, right? You looked at other platforms first. I know that like one of the ones that you looked carefully at was Hashgraph, and obviously you guys have built on Ethereum. Like, what was it that made you choose sort of Radix as the place that you were going to build?
Yeah, so we've looked at a ton of platforms and consensus algorithms, because we've been in this space for a really long time, and we were literally at the edge of our seats waiting for the industry to scale. And I discovered Radix from like a lone Forbes article, and my first thought immediately was like, wow, have I been studying like the wrong platforms this whole time? But no, it really seemed that the notion of Radix's sort of relativistic approach, especially in the early days of Tempo, really seemed to be the first platform that understood how value gets transferred and how like sort of truth propagates, I guess you could say. And it was the notion that was shardable, that was fully scalable in a horizontal fashion while still being scalable on a per shard basis at the same time. That was a real breakthrough that we hadn't really seen before. And that's how we knew it was quite obvious that Cerberus was something else.
It's one of the geekiest parts of Radix, and it's the bit that like it always takes me the longest to explain to people. And when they understand it, they're like, oh, is this idea of being like, you don't have to order everything. You only have to order the things that are related, and consensus doesn't have to be done in a strict order. You can kind of go, well, these things aren't related, so we can parallelize consensus here, and we can just have the network agree. Like, the concept of multi-threading has existed on computers for decades, but the idea of multi-threading a ledger just doesn't make sense. And the only way in things like Ethereum, when you have like this mess of data that is just, you throw anything into a block, doesn't matter if it's related or not. You're just like, I need this transaction validated. And the same with the execution environment. It's not going, I only need to execute this small amount of state because I know that's what the state transition is for. And so instead of going, here's everything, it's like the simplest and most stupid way of building a computer, when we've got all of this incredible work that's been done over the last, 5-6 decades on how to make more efficient computing, that we just sort of went, oh, well, I mean, clearly you should just make sure that transactions are ordered at a data level so that they are related. When they're related, then they're in the same place, and when they're not related, they're not, and then just run consensus on them such that you only have to order the things that are relative to each other. But yeah, like people are like, I don't think the world has currently got caught up with it yet. We're still debating about how we can make a single thread run faster, right? Like, this is what Polkadot is. This is what EVM is.
Yeah, something that one of our favorite quotes is that perfection is achieved not when there's nothing left to add, but when there is nothing left to take away. We feel very much that sort of radical minimalism and elegance is what leads to like true results. And that's a big part of what we think Radix is doing very well, and what we aim to embody as well.
And one of the ironic things about the way that the industry has developed, like you said, it kind of mimics the way that we approached computer development. And one of the people that we often refer to in the DeFi industry is Dr. Leslie Lamport. And we refer to his paper on Byzantine fault tolerance a lot. And the funniest thing is, if you look through his website, a few articles down is the paper on Tempo's logical clocks, effectively, and the bakery algorithm that Notoros uses. And so we didn't realize it, but the same person that everyone said, here's the paper on like Byzantine fault tolerance, he had actually solved all of the problems the DeFi industry has, but only in the context of distributed applications. And no one had quite taken it to that next step of like, oh, you can do this in a blockchain too. And so getting to that level now, finally, is really exciting, because we're able to emulate the same sort of stuff that cloud computers are, where you just scale, just add more processors, just add more cores, add more nodes, and you scale horizontally, and you can build the biggest machine, and there are no limits anymore.
Right. And like this is, and the other thing that the industry never talks about, and I think is also insane. We did some calculations, right? So like Solana is like, we can do 50,000 transactions per second unsharded. And you're like, yeah, but what the hell are you doing with all that state? Like that's 500 gigabytes a day, conservative case at 50,000 transactions per second unsharded. And your requirements for your nodes are already like 64 gigabytes of RAM. Like, do you not understand how insane that is? Like as an architecture point, as a jumping off point.
Absolutely.
Yeah, that's like definitely something we talk about a lot. It's sort of so we sort of just see that sharding is not avoidable conceptually. You can't really get away from the notion that things need to scale horizontally.
Right.
All those other systems, they there's a lot of really cool innovations out there. And a lot of people have some really great thoughts about how to innovate upon the space. But if the only way to run the system is through a giant data center that costs tens of thousands of dollars a month, it doesn't really solve the problem. And likewise, a lot of systems will say that they can scale to millions or billions of transactions or unlimited throughput, et cetera, but they don't really ever qualify those statements with what the energy or computational cost would be. Right. Like, yeah, the system can scale to 1 million transactions per second if you convert the sun into a computer, but until that happens, it's not really scalable enough.
Right. All right, let's move on from how awesome Radix is. I appreciate all of the love, and let's talk about the sort of the Notoros bullish case. Like, what are you guys aiming for? What do you want to achieve with what you guys are building?
So we see blockchain in 5 or 10 years kind of being as prominent as like Java is today, or was, several years ago. And by that we mean, every single device will run Notoros or will run some sort of blockchain application on top of there. And we expect that because of our flexibility and because of the strength and stability of our network and on top of Radix, we think that we will be that, final like 6 billion devices run Notoros sort of tagline will be there. And it won't just be that, it'll be all of the devices from your handheld devices up to enterprise grade servers will be running this for all sorts of different applications. And you'll see that the economy and the way that you like interact with things, you won't actually notice that you're running on a blockchain anymore. You'll just notice that all of the things that you expect to do, like when you go and pay you pay with your credit card, when you pay with your tap to pay with your phone, when you go to the store and you're like pre-order your stuff ahead of time, it just all gets a lot simpler. And all of those things are going to be backed up by blockchain on the back end, because blockchain makes those things simpler.
What's really cool is Notoros allows those applications from anywhere, developed by all sorts of different developers with all sorts of different styles and goals, to all coexist and bring their technologies together and make them operate very, very easily. So we can get to the sort of the convergence parts of this technology sooner and faster.
There's a really interesting debate here, and like the fact that Notoros is building on Radix means that the debate is sort of more open. But one of the paths that we always sort of went down with Radix was, at least for decentralized finance, the thing that makes these networks powerful is the fact that everyone is being enforced to use a particular standard. The standard being the Radix engine or the Radix engine v2. And that standard then allows sort of massive interoperability of all applications that are built on top of it from the point of view of native objects, right? So like USDC exists on Radix and you can move it from one application to another without having to think about anything like bridging or like incompatible virtual machines or anything like that. And from the point of view of finance, I always think about this, like what's the network effects? What's Metcalfe's law of DeFi? And for me, it's the number of applications that can interoperate times by the amount of assets that those applications are able to interoperate with, because that's what creates the liquidity. That's what creates the sort of like velocity of money and use within the system for decentralized finance. However, there's this other school that says, well, you know, that forcing of a standard is restrictive. It means that you have to build in a certain way. You have to use, in our case, crypto. You have to then build your decentralized finance applications in a certain way, which, you know, enforces conformity, which is good for making sure that you end up with these sort of, you know, high interoperability applications. But it does mean that you're forcing a particular path, whereas Notoros gives you this option of being, okay, well, we can have multiple different virtual machine types all running, and from a consensus security point of view, they're all as secure as the Radix ledger is, because you're relying on the consensus layer of Radix. However, they're not as interoperable, right? Like I can't just talk easily between them, or is that not true?
So it's a matter of what you consider to be talking back and forth. So as a programmer, as a developer, passing data directly from the one to the next is going to be something that's going to be very difficult. Something that can be accomplished with some additional tooling, just maybe another layer 2 solution. There's a bunch of different solutions that you can do to do that. However, I think that the interoperability of applications is going to be, in a way, itself sharded. So if you look at so for example, you said USDC. So there might be a smart contract out there run by a company who has, you know, its own supply of USDC that it's operating on, and it creates its own token. And if for some reason, you know, let's say that smart contract has some failure in it, that company is legally obligated. They can't just say, oh, the smart contract failed and like you lost your money. They're legally obligated to give you your money back. And that's where the domain of blockchain breaks away from the domain of what businesses actually can do and what they need it for. So the businesses, they need to show that your transaction request was sent in, that it's there forever, and that there was some action that was done upon it. But if you are suddenly rejected from the system because you're a terrorist or something, then that's like a legitimate business concern for them. They don't want you interacting with their system. They need a way to be able to say, oh, actually, we didn't handle this edge case, so we're going to go back, roll it back, and say this transaction is not valid. And when you do that, when you do those kinds of rollbacks, we saw this happen with Ethereum. When the Ethereum Classic forked away from Ethereum, all of the miners that believed, yeah, we believe in like this is the way Ethereum should be ran, and everyone else was like, nope, we need to protect it. We need to protect our holdings. Like we can't have this guy like running around with 1 million Ethereum anymore. That was
law. That was so controversial at that point. Yeah.
Absolutely. And that kind of like exemplified the problem here, which is that some people say code is law and some people say actually there are real laws to be enforced here. And so the network, what happened to Ethereum is the network had to split. The miners could no longer validate those transactions. Right. And so Ethereum suffered this major security like loss. And because more miners means more security, less miners means less security. And so what we say is that, yeah, both of those chains are good. They both are recording history. They're both recording things that people said that they wanted to do. And the way that you interpret it then has simply diverged. So with Notoros, we're giving businesses that flexibility to simply say, okay, we're going to interpret this a little bit differently because we don't think that this particular thing is valid. And if our users believe that this particular thing isn't valid either, then they'll go ahead with us and we'll have this like application level fork. And other people who do believe that that's valid, they can go off and do their own thing with it. And that might be the criminal aspect of it, but it's a decentralized system at that point, and you can't get away from whatever they're trying to do with the bits in their database.
That's fascinating. That's completely changing the idea of a hard fork. That's really, really interesting. And what's the first thing you guys are launching? What are you going to market with?
So we have first our EVM, which is what, we're calling it Ethereum Prime. It's the, basically the like core Ethereum. It's what we're going to officially support as a company. You'll be able to obviously fork that and run your own, separate instance on Radix if you want a different flavor of Ethereum. But the one that we're going to support is called Ethereum Prime. So we're going to be launching that first. And in addition, we're going to be launching what's called our Prometheus Network. And Prometheus is a relay network that allows you to send in Ethereum-style formatted transactions and have them put onto the Radix chain and then processed in Ethereum Prime. So what this means is that your normal tools like MetaMask and your normal tools like Remix and Hardhat and the developer tools that use Web3 will be able to natively use this Prometheus network to send in your transactions onto the Radix network and get the full benefit of Notoros and Radix while still maintaining just your regular Ethereum flavor.
That's really cool. So it's a little bit BSC-like in how it will work.
Yeah, so a little bit like that. And as a user, you'll be able to participate and be one of these relay nodes. And you'll be able to hold Radix and hold some of our Ethereum Prime's core token and relay these transactions in for people and then get some of their ERC20 tokens in exchange. And we have a lot of these tokenomics laid out in our FAQ on the website. And so it's going to be updated consistently, we expect. We have a lot more plans in the future for state-proving networks, for being able to decentralize storage of all the state that you're acquiring, and a lot of other things. But those are the first two things. Is we're going to make it so that instantly Ethereum on Radix, and then all of the Ethereum community can just jump right in. Did
you want to also add something, Andrew? I saw that you were...
I guess really just the notion that when we open up all of these very popular development tools that are used by the Web3 community, this also means that, if you are developing a dApp or someone who's already developed a dApp and you'd like to see it at scale with low transaction fees and not really have to change any of your code, we'd love to hear from you. Please reach out, because those are exactly the kinds of projects that we get so excited about. Is what can we do now that the limitations of things like gas fees and scalability are no longer problems? It's kind of the green fields that we always wanted blockchain to be when we first got involved in the space. We feel that green field is finally open.
That's awesome. And like it's funny because you guys have got such a great history in sort of building, delivering enterprise applications, and like enterprise has kind of fallen off the hot and sexy from the point of view of the crypto community, because decentralized finance has taken so much of the limelight. Have corporations stopped wanting to build things on blockchain?
Oh, far from it. We actually see even just the blockchain as a service industry is growing like 60% year over year, wow. Which is just breakneck speed. And we're actually working with a few different companies right now on pilot integrations of our technology where they can really see how it changes the conversation when it comes to their business. For example, we're working with a solar energy transparency provider, and what that's going to allow consumers to do is they're actually going to be able to take the energy created by the solar panels on their roof and trade it on capital markets and DeFi markets. So just imagine paying for your meal at the restaurant with the energy that was just generated on your solar panel earlier that day.
My dad would love that. He's an absolute solar. He's a solar nut. He literally built his own like mini solar farm at home. He runs like his electric car off it. He runs the house off it. He'd love that. That'd be right up his street. So like, awesome. What other applications are you seeing like corporate corporate appetite for?
Yeah, so we've also talked to we're also working with a defense contractor who creates really high quality sensors that can be used to secure and track all the elements in your supply chain, and report on the status of the fruit in the truck and those sorts of things. But what's really essential for them is, because they're a defense contractor, they need to be protected against infiltration on their supply chains and hackers and that sort of thing. And what's really great is we were actually able to turn around their entire integration in less than 48 hours. Which just sort of is a testament to how quickly you can develop dApps when any application environment is available to you.
That's super cool. So, you guys have mentioned tokens a couple of times. Do you guys have a token? When token? And give us a little bit of a taste of the token economics you guys have put together.
Yeah. So when you look at tokenomics, it really breaks down into a few core responsibilities for what are you paying for. So at our core level, at the submit it to the blockchain level, we have XRD, for Radix. So you pay XRD to get it into the blockchain. On the VMs themselves, for example, in Ethereum Prime, you'll have the core Ethereum token there, and that will pay for the processing. So the various nodes around the network need a way to not be DDoSed by the transactions that they're trying to process. That's what this crypto does for them. So those two things are the core, gets you up to Ethereum. Then we also want to have state proving networks for light clients, so that light clients don't have to download anything. They can just say, give me some zero knowledge proof, and I'll take it back, and I'll be able to know that I can go from there. And that requires its own sort of tokenomic strategy around there, so that you can get a network and incentivize it properly. We also want to create a network that stores that state forever. So not just what is it currently, but you can also say, what was it in the past? That will have its own tokenomic system built around it to incentivize that. All of these are data supply and distribution sort of mechanisms. And so we expect that you'll have data tokens that are wrapped around those. So as a node provider, if you're doing your full stack, you might actually have 4 or 5 different token economies running in your stack at once, where you're using data tokens to provide the APIs, you're using storage and data proofs in order to get additional ERC20 tokens, and then converting all of those potentially into another core crypto for a VM. And because of the way that we're interoperable with a bunch of different things, if you have an idea for a better tokenomic system, you can do that. You can just take our thing, fork it, create a new flavor, and if people like your flavor more, then that's great. That's what we're here for. That's what decentralization is about. It's about creating, as a community, the best solution that's out there for everyone. And because we can migrate, and we don't have to, like we just mentioned before, hard forks aren't really a problem for us. So if we're thinking, this state proving network's not really working out, we'll modify it slightly and move it along. And we retain all of the security and all of the trustlessness of that core initial network. So we have those big plans in the future, but like I said, the core thing right now is going to be this Prometheus network. That's going to be the main thing, I think, that's going to drive tokenomics in our system, because that's going to be how much do people want to be able to use this system, and how much can we get people to hold Radix and get them to relay these transactions. So a lot of different things all working together in that.
Awesome. And so what are your immediate plans for Notoros over the next 3 to 6 months?
Yeah, so we're gonna continue working with companies on a private basis, proving out these more and more sophisticated use cases. We're also prepping for the launch of our network launch on top of the Radix network after Olympia, probably within a few months of Olympia's deployment towards the end of the month. And we're also going to, be building out a lot of things that really make it easy to onboard whatever it is you're building onto our system, and make it so that sort of we need to close the gap for developers, because right now the development experience in the blockchain world is hard, and there's lots of tribal knowledge. you could be scrolling for hours on forums and Stack Interflows before you're ever going to find an answer, if you ever do, for most problems. So we're really trying to close that gap, make it so that regular people, regular businesses can use their technology on a blockchain at scale without it breaking the bank or breaking the code.
Awesome. And like, I see you guys are sort of planning to do some stuff with Avanti Financial Group. You're looking at stuff like with StoreJ and Ocean Protocol, and like how's that all coming in as well?
So we have a partnership on paper inked with Storage, and we are very excited to be working directly with them and getting our system integrated with theirs. We expect that we'll be able to do their transaction settlement for them eventually and take over that entire responsibility. Because they're still settling on Ethereum mainnet. It's like a very slow and arduous process for them.
That's insane. I hadn't realized that they were still like, oh wow, okay, cool.
And
so
really, yeah. we've been picking out a lot of partnerships based on what we see as people solving the real fundamental problems in the space, right? Radix is solving consensus. We think Storage has a great model when it comes to the governance of distributed data. We're also super excited about multi-party computing, or compute by side, where we actually glean insights from encrypted data so you can train machine learning models. And really, like, sort of all of these are the same infrastructure that we use for the modern internet today. But we are bringing together the pieces of what we see as the decentralized elements that really solve those problems on a deeper level in a more decentralized way. So, really any project that's doing that really well, we want to know about them. And we'd love to talk to you if you're solving a big problem in the space.
That's really, really cool. I mean, like, sounds like you guys have got a super exciting year coming up. Like the 3 months away from mainnet, give or take. You've got your sort of these partnerships lined up. You've got your corporate clients lined up. Looks like it's going to be a very busy year for you guys. If people want to find out more about Notoros, one more question actually. Notoros. Because I originally read it as Notorious. Obviously, it's not Notorious. And then before that, it looked like No Ether, but it wasn't. It was Notoros. So, like, what's the story behind the name?
So, Notoros is note, which is to record, hora, which is time, and os, which is sort of OS. So it's a time recording operating system that allows you to deploy any kind of application.
Yeah, before that we were called Noter, and that's the German mathematician, and who's kind of laid some of the foundational math for Einstein's theory of relativity. And so we were like, oh, this is a great callback to someone who really deserves some recognition. Everyone in DLT loves mathematicians as well. So it's like everyone wants to throw around these big names.
I mean, we're called Radix. So I mean, like...
Yes, exactly. And so we did notice, though, that there's a few people that had that same idea. And so we came up with our own branding. We wanted to kind of be distinct from everyone else. And that's where we came up with Notoros. And we feel like it's a much more clean depiction of what we do. Yeah, it's a very, there's a lot of different things. And we still kind of call back to that Noter kind of foundational aspect of it.
Cool. And like, if people want to find out more about you guys, where do they go? Where do you guys hang out? Where can they read more?
Yeah, so I'd highly recommend anyone who's interested in learning more, follow us on Twitter at Notoros DLT. Check out our website, notoros.io. That's Notoros. And we also have a subreddit, our Notoros. We're going to be launching a Telegram channel soon. So there's lots more to come.
All the cool places. Awesome. Well, Brendan, Andrew, it's such a pleasure to have you. Thank you so much for coming on.
Thank you as much.
Thank you for having us.